In chemistry, titration is a technique used to determine the concentration of a substance in a solution by reacting it with a solution of a known concentration. This process involves carefully measuring the volumes of the reacting solutions used, and based on the stoichiometry of the reaction, the unknown concentration can be calculated. Here's a general outline of how titration works. Setup: a solution of the unknown concentration, the analyte, is placed in a flask or a beaker. A reagent of known concentration, the titrant, is slowly added to the analyte using a burette. The titrant reacts with the analyte to produce a new compound. Indicator or pH meter: in some cases, an indicator is used to signal when the reaction is complete. An indicator is a substance that changes color when the reaction reaches its endpoint. Alternatively, a pH meter may be used to monitor the pH changes during the reaction, especially in acid-base titrations. Endpoint determination: the point at which the reaction is complete is known as the endpoint. This is often indicated by a color change, if using an indicator, or a sudden shift in pH, in acid-base titrations. At the endpoint, the moles of the titrant reacting with the analyte are stoichiometrically equivalent to the moles of the substance being analyzed. Calculations: once the volume of titrant used to reach the endpoint is known, the concentration of the analyte can be calculated using the balanced chemical equation and stoichiometry. This is based on the concept that the number of moles of the titrant used is equal to the number of moles of the substance being analyzed. Titration is a widely used method in analytical chemistry for determining the concentrations of acids, bases, salts, and other substances in solution. It is essential for quality control and research purposes, as well as in various industries such as pharmaceuticals, food and beverage, environmental analysis, and more.